Hey everyone, this is Sanjeev from KodeKloud, and today we're going to take a look at a tool called Pulumi. And if you don't know what Pulumi is, it's an infrastructure as code tool, which allows us to define our infrastructure, whether it's in the cloud or even on-prem. It allows us to define our infrastructure as code. So we can define it in code and our infrastructure will get created as per what we define in our code. Now, Pulumi is a little bit different than some of the traditional infrastructure as code tools like Terraform or CloudFormation. And in this video, we're going to go over what those differences are and why they can be a little bit of an advantage to us. And then we'll do a short demo deploying a few resources onto AWS using Pulumi. So let's go ahead and get started. So what is Pulumi? Let's talk about how we would traditionally deploy resources onto AWS. Usually we would log into the console and we'd click on a few different buttons or menus to deploy resources onto AWS. Now, with Pulumi, Pulumi is an infrastructure as code tool. So it allows you to define your infrastructure as code. So we would write our code that would define what we want our infrastructure to look like, and then our code would then deploy the resources. So we're defining it like traditional code like we would for an application. So what are the benefits of using an infrastructure as code tool? Why would we want to ultimately define our infrastructure as code? Let's say you as the user, you want to create 2 VPCs with 5 EC2 instances in each VPC with 2 RDS instances. The great part about infrastructure as code tool is you could send these instructions to your infrastructure as code tool and define them in your code. And what your tool is going to do is it's going to take the desired state, which is everything that you just requested. It's going to take a look at what's currently deployed onto your cloud infrastructure, and then it's going to perform all the necessary actions to get the current state to match the desired state. So you define what your infrastructure should look like in your code, and Pulumi or any other infrastructure as code tool is going to figure out the rest. And that's one of the benefits of an infrastructure as code tool. You define what you want, and the tool does the rest for you. Another benefit of using an infrastructure as code tool is it's very quick and very easy to deploy your entire infrastructure. In fact, all you have to do is just run like a single command. And the commands can be different depending on what tool you use, but essentially it's going to be something like deploy, and it's going to deploy all the resources that you have defined in your code. One command is going to deploy everything for you. And you can obviously make your infrastructure as complex as it needs to be. And I want you to think about how much time that saves you over going through the console or even using the CLI or the SDK to individually deploy each one of those resources. So you get to deploy it with just a single command, and it's just as quick to destroy all of them. Now, those benefits are nice, but I think one of the best benefits of using an infrastructure as code tool is because it's defined in code, we can treat it like any other application code, which is we could take advantage of Git, because ultimately it's just code. And just like any other piece of code, you can store it within a Git repository. So when we store our code in Git, we can obviously take advantage of being able to share our code with all of our team members and potentially anybody on the internet if you decide to make it a public Git repository. We get to take advantage of being able to share our code with many other people using infrastructure as code, which obviously, if we were just clicking buttons in the console, it's hard to tell another person, okay, this is the way the environment's supposed to be set up. Instead, you could just say, here's my code. You just run an apply or a deploy, and you're going to have a matching environment to the one I have in my environment. In addition, I think one of the most important aspects of Git is ultimately versioning. So since we are now storing our infrastructure as code, we get to actually version our infrastructure. So we can see documented in our Git repository all of the changes we make to our infrastructure. And if for some reason we make a change and all of a sudden our infrastructure goes down or we start to see a whole bunch of issues, it's very easy to roll back to a working state because it's all defined in code. So how does Pulumi ultimately differ from traditional infrastructure as code tools? With traditional infrastructure as code tools like Terraform or AWS CloudFormation, if you don't know what CloudFormation is, that's AWS's kind of specific infrastructure as code tool. The problem with these tools is that they usually use traditionally a domain-specific language. So Terraform uses HCL. So these are almost like custom languages that were created for the tool themselves. And if they aren't using domain-specific language, they might be using something like JSON or YAML. And these tools they're perfectly fine. They're designed to be as simple as possible. But you're going to find that there are some drawbacks to using these domain-specific languages or YAML to define your infrastructure. So the first thing is ultimately you're going to have to learn a new language. All your team members are going to have to learn a new language. Now, I don't think this is a major drawback because, like I said, they're meant to be as simple as possible, so there isn't too much to learn. However, just keep in mind that is something that needs to be done. You're going to have to understand the syntax and all the different features that are supported and the features that are not supported as well. But more importantly, you're going to find these languages tend to be very inflexible. So as you start to write more and more complex code, once you start adding in conditionals and loops, you'll see that these languages start to show their weaknesses where they don't have the flexibility of a traditional like programming language or something like that. On top of that, since these domain-specific languages are specific to one or two tools, you're going to see that there is a small ecosystem around them. There isn't a lot of tooling around them with a lot of different features that can help you make your life a lot easier. It's just not as heavily used, so you're not going to see a lot of people building an ecosystem around these domain-specific languages. And ultimately, there isn't a lot of reusability in these tools. With the traditional programming languages, we have a whole bunch of different entities or items that we can use to make our code reusable, whether it's functions or classes and things like that. You'll see that these languages, these domain-specific languages, just don't have that. And so the whole idea with Pulumi is that when we go to define our infrastructure, we're actually going to be defining it with using a traditional programming language like Python or JavaScript or Java or Golang. And so there's a lot of different languages that are supported, but the main idea is that we're now using regular programming languages to define our infrastructure. And there's a lot of benefits to this. Obviously, most likely your team members are already familiar with a programming language or two. And so you're going to see that they're able to pick it up a little bit quicker because they don't have to worry about learning a brand new syntax or a brand new domain-specific language. They could just use their favorite programming language. On top of that, we get the full benefits of using our IDE because we use our IDE to develop applications. We can use that same IDE to develop our infrastructure now because ultimately we're using a traditional programming language. So we're going to get all the features of our IDE, all the IntelliSense, all the refactoring capabilities of our IDE. On top of that, we have access to the languages package manager and all of its third-party libraries. So if you're using JavaScript, you have access to all of the libraries on NPM. And with Python, you've got all the libraries on pip. So it allows you to have a lot more flexibility when it comes to how you're defining your infrastructure in code because now you have access to all of those tools. And on top of that, all of the tooling and ecosystem that comes around programming, you're going to now have access to. So all of the linting, the different formatting capabilities, as well as the testing libraries. So you're going to find that because you're writing your code in a traditional programming language, you can now do unit testing very easily because most programming languages have some unit testing framework already that you're probably already a little bit familiar with. And also setting up a CI/CD pipeline is going to be a little bit easier because you're writing your infrastructure in a programming language. Most likely, you've already set up a CI/CD pipeline using that language before. Obviously, there's going to be some tweaks because you're working with infrastructure instead of applications, but you'll see that getting a CI/CD pipeline set up and running with Pulumi, because you're using regular code, is going to be a lot simpler than if you were using it with a traditional infrastructure as code tool. And so that ultimately is what Pulumi is. So let's go ahead and take a look at how we can deploy some resources onto AWS with a quick demo. Now, to get started with Pulumi, the first thing that we have to do is install Pulumi, and that's going to vary depending on what your operating system is. But if you go to the installation page for Pulumi, you'll see that if you're on Windows, you can get the installer directly, or you can use something like Chocolatey. I prefer to use Chocolatey, so you could just run choco install Pulumi. The same thing goes for macOS. For macOS, you can do brew install Pulumi, and that's going to get Pulumi set up for you. You guys shouldn't have to do anything else outside of that. Now, after we get Pulumi installed, the second thing we have to do is set up the credentials for authenticating with our cloud provider. So for this demo, we're going to focus on AWS, and the configuration for setting up the credentials for AWS is the same exact steps that you would use for setting up credentials for using the AWS CLI. So you could do a couple of different options. So you can either set up the environment variables using the AWS access key _ID, or as well as the AWS secret access _key. Or if you want to, you could set up the AWS CLI and then just run AWS configure, and then you will get the prompt for filling in these values, and that's going to configure the .aws/credentials files, which Pulumi will use. So usually you'll find that most tools ultimately use whatever authentication method that you traditionally use for AWS anyway. So if you use the AWS CLI, you could just run this command and run that, or you could just use the environment variables. So the next thing that we want to do is we want to bootstrap our project. And so Pulumi makes this very easy. They have this command called Pulumi new. And so we're going to run this command, and you're going to see that we can select, which cloud provider we're going to be using as well as which language. And that's going to set the basic configuration up for our project so we don't have to worry about this. So I'm going to do my project in Python, and this is going to be working with AWS. So I want to look for AWS-Python. So let's just scroll down a bit. So here we can see the AWS section, and we want to look for AWS-Python. And I'll select that. We'll give it a project name. I'm just going to use the default for the directory, which is Pulumi-demo. I'll leave that. Project description, don't worry too much about that. Then we're going to get this question for a stack name. And so what exactly is a stack name? So a stack is a isolated, independently configurable instance of Pulumi. So you might have, for this project, you might have a different stack for each one of your environments. So your dev environment might have one stack, your production environment might have one stack, your staging environment might have one stack. So that way you can kind of keep all the different environments separately, but they'll all have the same exact configuration. So I'm just going to leave this as the default of dev. So this will kind of represent our dev environment. And then we'll select the region we want to deploy into. I'm going to use US East 1. Feel free to select whichever region you guys feel most comfortable with. And then it's going to go ahead and bootstrap our project. It's going to create a virtual environment since we are using Python. And it's going to configure all of the Pulumi configuration so that we can get up and running as quickly as possible. Now, this does take quite a bit of time, so I'm going to go ahead and pause the video for now, and then I'll touch base with you guys once it's finished setting up. Okay, so it's finished setting up our project, and if we take a look, it's actually created a couple of different files. First of all, it's created a virtual environment because we are working in Python. It's set up a git ignore file. If we take a look at the requirements.txt, these are going to show packages that were installed. So we can see Pulumi was installed, as well as Pulumi-AWS. So this is going to be all of the code when it comes to interacting with the AWS API. If we had set up a project for Azure, you'd see something like Pulumi-Azure. Now, all of the code, the boilerplate code for this example project that gets created for us is going to be stored in this main py file. So if I pull that up, and I'm going to just minimize the terminal, we can see we've got some very basic code here. So we're importing Pulumi, and then from the Pulumi_AWS library, we're importing S3. And so here we can see we're going to create a S3 bucket. So here, if you just call S3, which is what we imported here, and then call bucket, and then give it a name, this is going to create a bucket for us and store it in this variable bucket where we can reference it at any other point in time in our code. And then we have an export. So these exports or these outputs, sometimes after you run your code, you want it to output some information. So in this case, it's going to output the bucket name. So it's going to print out bucket name, and then it's going to grab the ID of the bucket. Now keep in mind, when we create a bucket and we give this name right here, this is not what's going to be the name of the bucket on AWS. This name is strictly just for Pulumi. Pulumi, when you see when it actually creates the bucket, it's going to use this name and then append some extra random text to make it unique. But this is not going to be the final name. It's going to look a little bit differently, but I'll show you guys that. But this is a basic example that Pulumi automatically generates for us. And so we can actually go ahead and just run this code as is. It's going to create the bucket, and then after the bucket gets created, it's going to output the name of the bucket. So let's go ahead and test this out. To actually deploy the code that's created here, we're going to run a simple command. And the command is going to be Pulumi up. So Pulumi is now going to go through all of the code that we've configured. You can see here, it's going to tell you all the things it needs to create. It's going to show you all the things it needs to destroy and all the things it needs to modify. Now, since we originally started off with nothing, this is a brand new project, brand new infrastructure, and we haven't deployed anything, you could see since we've configured it to deploy a S3 bucket, the only thing it's doing is adding an S3 bucket. So this little plus sign just means we're going to create something. And you can see that on the side. You can see we're creating this. So it's going to create the stack, and then it's going to create what's in the stack, which right now is just an S3 bucket. So it's going to create those two resources for us. And then there's going to be an output of the bucket name. This can only be filled in once we actually deploy it. So we have two options, or three options technically. You can go ahead and deploy it with the yes. If you don't like the changes, you can do no. But if you want to see more details, we can say select the details, and we can see more specific details on what's actually going to get created. So let's go ahead and deploy this. I'm going to select yes. And this is going to go ahead and create our S3 bucket. And after it's created, you're going to see the output. And so under the output, you can see the bucket name. And so this is going to be the name that's created. And like I mentioned, originally in the text, if we actually go back to that, we can see we gave it my bucket, but the final bucket name was my bucket dash and then some random text. So like I said, this is not going to be the actual name. This is just used for Pulumi. Pulumi is going to generate a unique name for the resources that you create. But this actually went ahead and created the S3 bucket for us. So let's go verify in the console that this bucket was actually created. All right, so I'm in the console. Let's go to S3 and let's take a look and verify that the bucket did in fact get created. And so I've got a couple of other buckets, but if I zoom in, we can see at the bottom, we've got our my bucket. So this proves that it was in fact able to create the bucket that we specified in the code. All right, so I'm going to now run Pulumi up again. Before I actually run this, I want you to think about what's actually going to happen if I try to run this again. Is it going to try and create a new bucket? What's going to happen? Is it going to delete the old bucket, create a new one? Remember this. The whole idea behind infrastructure as code is that you define what you want your infrastructure to look like, and the tool is going to take a look at what's currently deployed and make sure it matches up with what's in our code. So since we say in our code we want one bucket called my bucket plus the unique identifier, what should happen is Pulumi should take a look at the resources deployed on AWS and see, do I have a bucket called my bucket? If I don't need to do anything else because that's all the code is telling me to do. So the whole goal of Pulumi is to see what you want, which is in our code, and what's deployed on AWS. And it's going to make sure that they always match. So if I run Pulumi up, ideally, it should not do anything. It should say there's no changes necessary. And we could see here, resources unchanged too. So it's basically doing nothing. So we could just go ahead and hit no for now. So I just wanted to highlight that fact. It's only going to make changes if there's a deviation from your desired infrastructure configuration. So let's now add some more resources just to make the project a little bit more interesting. I want to create an EC2 instance now. So from the Pulumi_AWS package, I'm going to import EC2. I'm going to show you how easy it is to deploy an EC2 instance. So once we get our EC2, I'm going to go down and I'm going to create a new variable. I'll just call this EC2_instance equals, and then we're going to define our instance. So I'll say EC2.instance. So this is how we create an instance. And there's going to be a couple of properties that we have to pass it. So the first thing is we're going to give this a name. And remember, this name, once again, is not going to be the name of the instance on AWS. This is just going to be the name used within Pulumi. I'm just going to call this web server. And then there's going to be a couple of properties that we need to create. So, or pass it. And so the first one is going to be the AMI. And so I'm going to grab the AMI from the console, and later on in this video, I'll show you guys how we can use this all through Pulumi. But for now, I'm going to go to the console, get the AMI of a Ubuntu image. So I'm going to search for EC2, and I'm going to select instances. We'll go to launch instance. And I'm going to select Ubuntu here, and I'm going to grab this AMI ID, and we're just going to pass it in as a string. Now, the next property is going to be the instance type. So here I'll just do instance type. And, the great part about using a programming language is you could see all the IntelliSense, right? It's auto-completing for us, right? If I type in instance type, you can see it already knows for the EC2.instance object, there's going to be a property called instance type. And I'm going to select this to be t3.nano. Then if you have a specific, key that you're going to use for authentication, you can use the key name property. So I've already got a key set up in my AWS console, so called test1. And that's what I'm going to use for authentication so that I can connect into the EC2 instance after it's deployed. And then we're going to specify some tags. So I'll say I want a name tag, and that's going to be set to, I'll just call this web. All right, and so that should be everything we need to create an instance. The last thing I want to do is I want to set up another output. So I want to be able to get the public IP address of the server in the output. So I can do a Pulumi.export, and I'll just call this public_IP. And then we'll grab the EC2 instance. So we're going to reference this variable here. So I'll do EC2_instance. And then we can just look through the IntelliSense to see what we want. It's probably going to be called public IP, and that's exactly what we want. So this should print out the public IP after it gets created. So let's go ahead and run a Pulumi up now. And I realized there's a typo under tags, so let's fix that, and let's run this again. All right, and so now, if we take a look, they're saying that, first of all, there's two things that are unchanged, so that's going to be the stack and the S3 bucket, because remember, we didn't change anything when it comes to the configuration of the S3 bucket. The only thing we've changed is we need to add an AWS instance. So Pulumi is intelligent enough to know, okay, you want a S3 bucket, and you want an EC2 instance. Well, we already have an S3 bucket, so that means I only need to add the EC2 instance. And that's why it's only going to configure an EC2 instance. So let's go ahead and deploy that. All right, and it was successfully able to deploy, and you can see it even printed out the public IP. So now I can use this IP address to SSH into the box and make some changes to it. All right, so I'm going to copy this address now, and I'm going to try to SSH to it. So I'm going to pass in the PEM file, and the default user for an Ubuntu AMI is going to be Ubuntu, and we'll try to SSH to it. So right now, I can see that for some reason I'm not getting a prompt, so it looks like there's some sort of connectivity issue. So let's go and troubleshoot this. So if I go to my instances, and I go to my running instance, which is the web, and I go here, usually when there's a connectivity issue, I usually like to take a look at the security groups. And we can see here there's a security group with a rule that's saying we're going to allow all ports, all protocols, but only from this source. So only from this security group, which is not going to be my machine. So it's probably, the connectivity issues is probably due to this security group. So let's go ahead and create our own security group within Pulumi so that we can allow just the ports that we need so that we can actually connect to it and set up whatever we would like. So I'm going to go back to my code, and I'm going to create a security group. And I'm going to do a security group with 2 inbound rules and 1 outbound rule. And so to create a security group, I'm going to go right up here above the EC2 instance, and I'm going to call this SG for security group. And so we just say EC2.security group, and then we'll give this a name. And since this is going to represent a web server, I'll call it web server security group. And then I'll give it a description, and I'll say security group for web servers. And so that's going to create the security group, and then we're going to create the rules. So here I'm going to create a rule to allow SSH. So I'm going to call this allow SSH. And then here we say EC2.security rule. So you want security group rule. And we'll give the rule a name. I'm going to say this is allow SSH. And then there's going to be a couple of properties that we have to pass in. So first of all, the type, this is going to be a ingress rule. And so the from port is going to be from port 22. And the to port is going to be 22. So it's only going to allow port 22. And then the protocol, this is going to be TCP. And then for CIDR block, I'm going to allow everything. And then this rule, we have to now associate it with this security group. So we want to say this rule should be attached to the security group we created in the line above. And so we say security group ID equals, and then we provide the ID of this security group. So this security group variable, this SG variable, gives us access to the whole security group object. We don't want the whole object. We want the ID property. So I could say SG, and then I'll do a dot, and I can grab a property from that security group object, and we can grab the ID property. And so that's all we need to do. And I'm going to copy this, and I'm just going to paste this, and I'm going to tweak this. So I'm going to say this is going to be for allow HTTP, because this is going to be used for a web server. So I'm going to just rename this HTTP. And all I have to do is just change the ports. So HTTP is port 80. So we'll change the from port and the to port to port 80. And then finally, I'm going to create one more rule. And this is in the egress direction. I want to allow all egress traffic outbound. And so I'll call this allow all. And the type is going to be egress. And the to port and the from port, we're going to set to 0, which means it's going to be all ports are allowed. Protocol, I don't really care what protocol. So if you want to just allow all protocols, you just do a -1. And that should be all that we have to do. So this is going to create a security group. And now we want to attach the security group to our EC2 instance. And that's going to be easy as just passing in one more property. And so this is going to be VPC security group IDs. So this is going to take a list of security groups. So provide a list, and then we just reference our security group SG. But remember, it's asking for the IDs. So we have to do sg.id. So let's bring up the terminal. And let's run a Pulumi up. Oh, wrong terminal. And looks like I forgot to rename this. So you can see I named both of the rules allow HTTP. Definitely need to fix that. So this is going to be allow all. And we'll try that again. All right. And we can see we're adding in a security group, the 3 rules. And then since we now are attaching that security group to the EC2 instance, we can see the icon is a little squiggly line that's yellow, which implies that it's being updated or changed. So the resource is created, but we're changing some properties, which is we're attaching the security group. So let's go ahead and run yes. And this is going to make those changes. And so now let's go back to the other terminal and see if we can connect. And you can see we get a prompt. I'm going to hit yes. And we are now successfully connected to our Ubuntu machine. And while we're connected, I'm going to install a package. So I'm going to do sudo apt install nginx. So this is going to install a web server for us. And I'll just make sure that it's running. All right, perfect. And so now I'm going to go back to the other one, the other tab. I'm going to grab the IP address. And this should be in the outputs. So we can see here public IP. I'm going to open up a new tab. And if I go to that IP address, we could see welcome to nginx. So we are now successfully able to send a request to our web server because we opened up port 80. Now, what I want to do is I wanted to automatically generate the DNS URL provided by AWS. So I want to set up another output that'll actually print out the URL so that we don't have to use the IP address. So we'll go back to our code, and we're going to set up another output. So here, we'll just do pulumi.export. And I'll just say this is going to be instance underscore URL. And then here we grab the EC2 underscore instance. Remember, this is the instance object that we use to create the instance. And let's just look for a property that is probably what we're looking for. So if we keep scrolling down, there should be something that's interesting to us. Okay, here we go. Public DNS. This is what we want. So this is going to give us the DNS for this EC2 instance. I could save this, and we can run a Pulumi up to see the changes. So this shouldn't create any new resources. This is just changing the output. And so you can see here, just the instance URL output's getting updated. So we'll hit yes. And it's going to update that for us. And it's going to give us the DNS entry. Now, if you don't want to have to do a Pulumi up every time you want to get the outputs, there's a command you can run. So if you want to just get the outputs at any time, you can always run Pulumi stack output. This is going to print out all of the outputs. And so now we got the bucket name, we've got the instance URL, and the public IP. Now, what I would ultimately like is for it to automatically add http:// so I can just click it and it'll open up so I don't have to copy and paste. And we can actually do that using Pulumi. So we can add the HTTP beforehand because, we're just using a regular programming language. And so we're going to take this out here, and I'm actually going to, before it, I'm going to run this command. We're going to do pulumi.output. And I'm actually going to just delete this just to keep things simple. So this is going to grab the output object, right? So the output object is going to be all of the other outputs that are defined. And I'm going to run .concat. And I'm going to just concat these 2 strings. So I'll do http://. And we'll get the EC2 underscore instance dot public DNS. So this is just going to add http:// before the public DNS URL so that we can have a clickable link. So I'm going to run this again. And let me do a Pulumi up. All right, and so now you can see the URL that gets generated. And so I could just hit the control key on my computer, and now it turns into a clickable link. I can open this up, and we can see it takes us to that same Nginx page. All right, so now let's say that we want to create 5 EC2 instances. And let's say we have an array, and I'll just call this instance underscore names. That's going to be an array that's going to have the name of all of our EC2 instances. So let's say we want 3 of them. And so the first one will be called Web1. The second one will be called Web2. And the third one will be called Web3. So how do we actually create 3 EC2 instances with these names? Well, this is just a programming language. So I think you guys can pretty easily figure out, like, all we have to do is just iterate over this array and create a separate EC2 instance for each one we're iterating and just change the name accordingly. So let's go ahead and do that. So I'm going to say for, and we'll just pick a variable. I'll say instance in instance names. So it's going to iterate over the array. We're going to just take this and we're going to just move it over. So I'll just tab it. Okay, so that's going to put it inside this for loop, and we'll just change the name. So this is just a string, so we can just put in instance, and we'll change the tag as well to be instance. And so now we're going to create 3 EC2 instances, and that's how easy it is, right? So creating multiple things, iterating over things, it's very simple with Pulumi. It's just a regular programming language. And we're going to have to update the exports. So I'm going to create an extra list, and I'll call this output public underscore IP. So this is going to be an empty array that's going to store all of the public IP addresses. And inside the loop, while we're iterating over it, I'm going to just do output public IP and then append the public IPs after we create the EC2 instance. So I'll just call EC2 instance dot public underscore IP. So that'll grab the public IP every time we create an EC2 instance and add it to that list. I'm going to just comment out the DNS, and here I'm going to swap this out with output public IP. So let's save this, assuming I've made no typos. I'm going to do a Pulumi up. We'll take a look at the changes. So we can see here we are deleting an EC2 instance, and we're creating 3 more. So I will then do a yes. And remember, it's deleting the original EC2 instance because we don't have an EC2 instance just called web anymore. We're creating one with web 1, web 2, web 3. So that's why it's deleting the old one. So I'll hit yes, and we'll let that run. All right, and now that was successfully completed. We can see the outputs. The public IPs of the 3 servers are listed here. And it looks like we have 3 EC2 instances now. Let's go to the console and just double check. So if I go back to AWS, we'll go to instances. We can see we've got our 3 EC2 instances, Web 1, Web 2, and Web 3. Now, when you're running Pulumi, you may have noticed this URL right here. So what is this URL? Let's take a look and see what happens when we click on this. So if you're not logged in to Pulumi, go ahead and log in so you could just sync your GitHub account. But what happens is this actually opens up a web console that's hosted by Pulumi that has information about the most recent Pulumi execution. So the last time we ran a Pulumi up, it's going to track everything that happened. So you can see here under changes, I'll zoom in for you guys. We could see that we added 3 EC2 instances and deleted one. If you want to do a diff, you can actually go ahead and see what changed, and this is going to show you all of the actual detailed changes. And you can take a look at the timeline, the configuration, as well as other details when it comes to your Pulumi. So this is just a nice little web GUI that you can take a look at just to monitor how the most recent run took place. So let's now go ahead and wrap things up by deleting all of the resources that we've created. And so to delete everything, we'll just do a Pulumi destroy. So this is going to delete all of our resources within this stack. And it's going to show us, right, everything turns red, which means it's going to delete all of this. And we'll just do a yes. And this should destroy all of our resources. All right, and so that's going to delete everything, and it should clean up all the things that we had created within this demo. So that's going to wrap things up for this video. We got a chance to dive into Pulumi and how we can use it to manage our infrastructure in code. And we got to see the advantages of using a tool like Pulumi, where we can utilize traditional programming languages like Python or JavaScript to actually define our infrastructure, because then that opens us up to the entire programming language, the entire ecosystem, and everything that the programming language has to offer. And we get to encompass that within our infrastructure as code. So I hope you guys enjoyed this video, and I'll see you guys in the next one.